Okay, in this video we are doing problem set 35, Calc AB, problems and playlist in the description below, and let's do it. Evaluate with outstanding work. I don't know why I started writing that on all my limits. The limit is x approaches 3 pi over 4, secant squared of x minus secant squared of 3 pi over 4 over x minus 3 pi over 4. This to me just looks like the definition of the derivative. Like, you might be in the mind of just doing L'Hopital's rule if you're in the L'Hopital's notes or whatever, or you just did the last problem set. But always be on the lookout for the definition of the derivative. I think here we're dealing with the function secant squared. The derivative of secant squared is going to be something squared is 2 times that thing, so 2 secant times the derivative of that thing, which is secant tan. So we get this, and we just need to evaluate this at 3 pi over 4. So we need to think of the unit circle, or whatever, however you memorized it. You need these values at 3 pi over 4, f prime of 3 pi over 4. So 2, negative root 2, sorry, I was doing 2 pi over 3, I think. Negative root 2 again, and then the tangent of 3 pi over 4 is negative 1. So overall, this will give us negative 4 for our answer. And don't forget, that's the answer to the limit. Like, we evaluated a derivative. I don't know, it's probably a good idea to go back and say that, therefore, is the answer to the limit. All right, next question. Given dy dx is 3y squared minus 5 over 5x squared plus 2. So this is an implicit derivative. We want to find the tangent line at negative 1, 4. So notationally, dy dx such that negative 1, 4. And then we plug in a negative 1 for every x we see and a 4 for every y we see. So we get 3 times 16 is 48 minus 5 is 43. And then 7 in the denominator. So 43 over 7. And then writing the equation of tangent line hopefully is super familiar at this point. I'm going to use point slope. Y minus 4 equals 43 over 7 quantity x plus 1. And that's a good problem. All right, next up. Find the distance traveled by a particle with position function x of t equals t squared minus 8t plus 12 on the interval from 1 to 5. Okay, so remember, distance is harder to find. There's 2 questions, distance and displacement. Displacement would just be x of 5 minus x of 1, and you would be done. Distance, you got to find the velocity, set it equal to 0, see if you change direction anywhere in the interval, so let's just do it. V of t is going to be x prime of t. We have to write that down. And then that is just by the power rule going to be 2t minus 8. We need to know when v of t is equal to 0. We don't actually need to look at the sign changes or anything because we're going to throw some absolute values around this, but that'll give us t equals 4. So our distance traveled is going to be, you went somewhere from 1 to 4, but we don't want to think about whether you went to the left or the right. So we do absolute value of x of 4 minus x of 1, plus you went somewhere between 4 and 5. We don't want to think about it, so we do absolute value x of 5 minus x of 4. When I say we don't want to think about it, we need to get a positive number there. We can't get a negative. We're not getting displacement. We want distance. So that's why we put the absolute value. I decided to do this by hand, even though I've been kind of wimping out throughout these and just using a calculator. So I made a table, I plugged in 1, I plugged in 4, I plugged in 5, and then I subbed them in. This is why I've been using a calculator. Is this fun to watch? I don't think so. Is it fun to do? Definitely not, at least for me. And then this will be 9 plus 1, which is 10. All right. Next up, a right triangle has legs A and B. If A is increasing by 3 inches per minute and B is decreasing by 2 inches per minute, find the rate of change of the area of the triangle when A is equal to 4 and B is equal to 7. I think we need a picture of a triangle. You probably definitely do this without a picture of a triangle, but it's helpful. So I've drawn a right triangle, and I labeled the sides A and B. Fine. The problem tells us that A is increasing, so dA dt is positive 3. And B is decreasing, so dB dt is negative 2. And now we're just going to write, usually it's Pythagorean theorem, but here we're talking about area. So we'll write down the area function. Area is 1/2 A times B. I'm using capital A for area and lowercase a for the side. Is that dangerous? Not in this problem, but it's not a great idea. I need to find the derivative with respect to t, which means capital A is a function of t, lowercase a is a function of t, b is a function of t, so all their derivatives are d whatever dt, and on the right-hand side we need to use the product rule. So dA dt is going to be 1/2 the quantity, first a dB dt, plus second b dA dt. And now it's just a matter of plugging in, so we know a bunch of things. Well, we know everything actually. dA dt is going to be 1/2. A is equal to 4, dB dt is -2, b is equal to 7, dA dt is equal to 3. So that's 21 minus 8 is 13, and then we're dividing by 2. 13 over 2 is our answer. I guess that's in, I wanted to say minutes squared. Inches squared per minute. I should have put units on that. I didn't. I guess I'll handwrite them. I hate handwriting live. Inches squared per minute. But you lose points for units on these, so you got to do it. All right. That's the problem set, I think. Yeah, that's the problem set. I hope this was helpful, and good luck.